Hi everyone, my name is Thomas. I work at Argonne National Lab, and today I will present my work on OvO, a framework to systematically test a subset of OpenMP Offload. We will start with an introduction, maybe about myself and mostly about this project, and what is the goal of this talk. Then we'll switch on hierarchical parallelism, the subset of OpenMP that it is tested by OvO. I will finish with some conclusion, and for the people who will download those slides, at the end of the PDF we'll have some backup slide for if you want to know more about testing of mathematical function. So let's get started. What is the goal of presentation for you as a viewer? So really in the nutshell, OvO is really about the functional testing of a subset of OpenMP Offload. So all this talk will be about how can one test if your compiler implement correctly OpenMP Offload and which subset. I would like to highlight really maybe the big difference with OvO compared to other testing of OpenMP. It is this systematic approach. We will test all valid code for really a subset of OpenMP Offload. And I really encourage you to use this tool with your own compiler and to report bugs that you will find who is important to you. And also, I will teach you maybe some OpenMP subtleties that were not trivial and I discovered when creating a test for this project. What I will not do in this talk, because we are a little short on time, is I will not show various pass rate for various compiler, because in this short time it will be more like a name and shame, because I will not be able to go really deeply into the detail and everything, so I will prefer to avoid. But if you are curious, you can just run this tool on your compiler and get the number. So what is OvO? So really OvO, it's an OpenMP offload mathematical and hierarchical functional test suite. So we'll test everything in the OpenMP specification related to hierarchical parallelism and mathematical. So we'll choose a subset and really generate all the tests corresponding to that. It is for C++ and Fortran. More precisely, all the tests are C++, 11 and F19. And I test really the last OpenMP specification, so today is 5.1. OvO, it's a test and a little script to be able to run the test, compile and check for correctness. So you have no dependencies. And all the tests are standalone. So it was one of the design principles. So that means when you find a bug, you can just take this test with one single C++ file or Fortran file and send it as a reproducer. We found a bug in all the compiler tested, and many of them were already fixed, so it's really good news. And some of them are still ongoing fix for the vendors. So due to time constraint here, I will really focus on hierarchical parallelism. But if you want to know more about how we can test all mathematical function, you can just see in the backup slide if you download the PDF. So why OvO? So I worked at Argonne National Lab, and one part of my responsibilities and day-to-day work is to ensure that we'll have a good compiler for Aurora. So Aurora will be an exascale system, will be delivered at Argonne National Labs. And for this project, Intel is developing a new compiler called ICPX. And one of my goals is to be sure to check that ICPX will be good quality and is already a good quality compiler. So for that, I need to check that ICPX, the one API compiler, can implement the specification. So the OpenMP specification is really large, extensive, and compiler only support a subset of it. I think no compiler can implement everything in the OpenMP. And for application developer, I think it's important to know when you're developing your code what subset of the OpenMP specification your compiler implement, and for compiler developer is also implements to know what you are, so you can fix those bugs, right? As an application developer, you want to know, so you can choose which version, which subset of the OpenMP you will use in your application, and as a compiler developer, you want to be able to implement the feature you don't have. So maybe the comparison to similar project who exists in this testing of OpenMP, we have the DOE ECP Sol verification and validation, I think, SolVV. And it is really extensive, SolVV. It tests all the specification. We have a good talk from last year presentation. If you want to see, I put the link here, and it is a nice presentation about the architecture and what they are doing. You're also IBM, who open source maybe 1 year ago, some of their tests that they manually wrote for OpenMP Offload, because it is a new area of development of the OpenMP specification. So test coverage was a little not sparse, let's say, so they open source this thing. And I think the key point of OvO is like I focus only on a really narrow subset of the implementation. I focus about hierarchical parallelism. I will define what it is next time, and only for OpenMP Offload. And the key point is I test all the possible combination of those hierarchical parallelism. And I think it is the main point, is like the tests are exhaustive. So what is hierarchical parallelism? So hierarchical parallelism is in OpenMP. OpenMP allows you to have nested region, nested parallel teams regions. And it is used really extensively in a lot of offload code. So for example, here I show you an example. I think it is maybe the hello world of hierarchical parallelism, of nesting region, nesting parallelism. So you see at the beginning, in line 1, we have this OpenMP target to say it is an offload region and will be executed on the GPUs. And after, I have a loop, we do team distribute, so I will create a league of teams, and after I will distribute my work across this team. And then inside each team, I will create a parallel region, and I will distribute my work over this parallel region, and then I will create inside this parallel region another loop with SCMD. And so you have different rules on how to combine all these pragmas. You can put everything on the one line, you can do other things. And OvO is really focusing on this kind of testing. So in OpenMP, for this kind of hierarchical parallelism for offload, we have only 6 directives. We have target, team, distribute, parallel for SCMD. And during my time, when debugging the preview alpha version of the Fortran compiler, I wrote manually a few tests, but it was really painful. And one day I read this nice article about testing mathematical function, and he was saying you have only 4 billion floats, so you can test them all. I think in this article it was about testing a floor function, and you can just test all the possible float in this test function and know if they are correct. And I was like, we can do the same for this really subset of OpenMP Offload. And this was the start of this project. So the goal is we have 6 directives. We have target, team, distribute, parallel for, and how many combinations of them we can do in OpenMP who are conforming. So if you are an OpenMP expert, you know that the answer of this question is infinity, because you can infinitely nest parallel region. I don't do that in OvO for the obvious reason that infinite tests are maybe too much test. So I'm just limited on one combination of these 6 pragmas. I will not go into the details on how to generate all the possible combinations. You need to read the spec carefully, and after you need to have a little algorithm, recursive algorithm, who is trivial to implement, and I put the link here if you're interested to see. I just put maybe 2 examples of conforming and non-conforming code. On this side, you see a conforming values. So you can do target team distribute on one line, then you can do a parallel and a CMD, and it will be a valid. A non-conforming code is you can do target teams, and after distribute parallel do a CMD. This is not valid. You are not allowed to do distribute and parallel. If you read the specification, in maximum you can have 16 combinations who are conforming. So it's not that much. It's only 76 tests that you can just generate, and all the possible combination. And if you do, for example, atomics, like I will show you later, the kind of test I generate, you will see that you have more restriction. For example, atomic cannot be strictly nested inside the team region. So for atomic, you have a little less test. But for example, reduction or just Memcopy, you may be able to generate 70 valid combination of tests. So what is the device and the scope of OvO? So we have three main categories of tests. We'll do tests who do memory copy, tests who will do reduction with the Pragma OMP reduction, and atomic with the Pragma atomic. Everything will be templated, so we can do a lot of data type, float, double complex, or this kind of thing. Double complex is interesting because it's big enough that the data type is big enough that a lot of hardware doesn't have atomic support for it. So you can trigger some of few bugs when using complex, and complex is really used in HPC quite a lot. And the correct thing is like we do it for C++ and Fortran. As I said maybe before, test as self-contained, so you can just copy paste. We do simple, we have simple norms, so it returns 0. The code should return 0, an exit code of 0 when everything is fine, and different of 0 when you have a bug. And the test is designed to be independent of the number of team and thread. So maybe now the first thing that it is generated by OvO. So OvO can either generate a lot of tests, but also if you git clone the repo, you will have a set of already given tests that you can run. So here is maybe the really simple Memcopy example in Fortran, where I just allocate array, then I put random number into it. I do this offload region target team distribute parallel do SEMD, where I map both of my variable, who is the array I want to copy, the source and the destination, and I will use a local index because of code generation issue. It's easier for me to generate this index, and so I need to say this index as a private. And at the end, I just compare that the source and destination are correct with some epsilon. Same for, I will discuss more later why I use epsilon and this kind of thing, and I don't do just purely equality comparison. And because I am clean, I try to disallocate the memory. So it is this kind of test that we generate, and as I showed you before, I generate all the combinations. For example, I split target and team distribute in another line, and I generate all of these possible tests for all these combinations of pragmas. So maybe a little subtleties in this example is you show that I put private. And I'm pretty sure certain people in front of their screen were saying you don't need to put private, because by default it will be first private. And it is correct. In this case, in OpenED target team distribute parallel to SEMD, it will be first private by default if you read the specification. Maybe a little subtleties is like if you split target and team distribute parallel to in two lines, the code now is incorrect. Index will not be first private. If you read the specification, index will be shared. So you need to be careful. The code I showed here will have a race condition in index because index will be shared. So you need to specify private. So this is why in OvO I prefer to always specify private, because first private introduce maybe once per use data transfer to copy first the data of index, and I don't care. So this is a little subtlety of the OpenMP specification. I show you an example of Memcopy. No, I show you an example, for example, of atomic and reduction. So I do the same thing of atomic reduction. You can do target team distribute parallel for SEMD reduction or with an atomic inside. But you can do also this Cuda style where you don't put loop because who likes loop? So in reduction and atomic, the tests are designed so the result of the reduction or the reduction via OpenMP reduction or the reduction via OpenMP atomics are known a priori, right? I know them at compile time. And I design the tests so the results are independent of the number of threads and the number of teams. So for example, here you see two examples of tests I generate with reduction and atomic. And you see this test will always give you 1 independently of the number of threads that the compiler chooses to generate in this target region. One maybe interesting thing about doing this exercise is to realize floating point arithmetic. We are not mathematicians. In the mathematical world, this example will always true 1. Because we do computer science, we use fixed and floating point arithmetics and fixed size floating point arithmetics. So in this case, the error will accumulate. And in fact, this code, the error is unbound because your compiler is choose to span 1 billion threads, so the error will be unbounded. So the solution is kind of trivial when you know it. You just need to specify a maximum number of threads and teams. The important thing of those tests is they don't rely on the number of teams. They are independent of the number of teams of the number of threads. It's because in OpenMP you don't have a way, at least no way I know, to really set the number of threads. Right? The number of threads will always be an upper bound. So you set the maximal number of threads, you do some mathematical analysis to compute the biggest theoretical deviation you can have for that, the maximum error you can have. And then you compare this value with tolerance. So this is a real code generated by OvO or directly in the repo, where I specify the tray to a big number. I think I choose this 32k because if you do the analysis of 32k, the biggest number error you can have will be less than 1%. And it feels reasonable. And then you can do the traditional reduction or atomic, and you can compare a counter 0, where here it should be equal to counter parallel, sorry, it's a typo, it should be counter parallel to 1 at 1% difference. So I show you how OvO take care of these floating point differences when you have unbalanced Cuda style, where the result of your computation depend of you really don't use loop, you span thread, and after each thread will perform this thing. What I want to show you, it's maybe a little subtlety to know with mapping and reduction. So in this case, if you split your target and your reduction, you will need to map the scalar. If you reduce the scalar, you will need to map your scalar to from. Because like I saw previously on the specification, by default, a scalar are passed as first private, so it will not come back. But if you merge targets and reduction, for example, you do target team reduction, you don't need to specify the map. It will be, because it is on a target clause and a reduction clause at the same time, on a combined construct of target and reduction, it will be mapped as to from. So you can simplify your code using this kind of trick. I mean, not trick, knowledge of the specification. This is a simple case that OvO can generate, but we can generate far more complicated when we have the framework to be able to generate tests. It's really easy to generate more complicated tests. For example, this one is a test that I think for now in my testing no compiler implement correctly. So it's a NOS parallel for, so the parallel for is executing on the host, and after inside this host, everybody will do an atomic to make a reduction, right? Reduction via atomic. This code should work because if you look at the specification, they say the reference counting and all this map for reference counting when to data transfer and everything should be performed as a single atomic operation. So this code is compliant. I think it's really hard to implement this code and a runtime who is able to handle this kind of use cases without huge penalties, but at least if your compiler implements the full specification, this code should pass. So the summary is, I try to show you that it is possible to test all combination of a subset of these offload directives, mainly these 6 target team distribute parallel for. I found bugs in all the compiler, and Clang have been really reactive to fixing all the bugs I reported, or they are found it internally, because I think now some people in LLVM community are using OvO to test their code. And I'm proud to announce that Clang 14 with this idea of passing some 100% of all the tests. Other compilers have a different kind of pass rate. I think everybody has still have some bugs, and mostly SCMD was really hard for compiler. A lot of compiler was giving eyes hanging with using SCMD, where you start putting SCMDs. So in the conclusion of this talk, here I put a simple example how you can use OvO. So it's really easy, you just need to git clone. You git clone, you set it into it, and after the only thing you need to do is to set your environment. So I use the CXX flags, CXX flags for the compilation of some option, FC, FF flags, and after you can just run it. It will run this, I think we have 900, 170 tests by default, and after you can just do OvO report, and it will give you a nice report with which tests are failing and the pass rate and everything. So really the main takeaway I think I would like to showcase is like we should maybe try to testing systematically all subset of the specification, because I found really strange bug where it was on really strange combinations and nobody would ever think of doing it. Lot of bugs that were discovered are now fixed, and I found bugs in already the compiler tested. Some of bugs are really, really low priority, and I understand that it is not a huge compiler. People don't have a huge incentive to fix this code, because nobody will write this kind of target team and after parallel and after SCMD or this kind of strange combination. But I think it's important to at least know that you have a bug in your compiler. The OpenMP specification have a lot of subtleties. It can really trick you. I would like to thank a lot of people who contribute, who helped me writing good bugs. So Johannes from LLVM, Hierarchical from Argonne, people from GCC, some mathematician who helped me for this FP analysis, because it's highly non-trivial to make understanding of all these subtle point of the specification and of the IEEE standard for floating point arithmetics. I would like to encourage you to use OvO and to report any bugs to your vendors or to me if you find bugs to OvO. I generate a lot of tests, and some of them are maybe wrong, I guess, because of the 0.3. Thank you very much for your attention, and don't hesitate to send me any email. I should be easy to find on the web. It's just my last name at anl.gov, and I will be on the SC Slack and everything. Thank you very much for attending this presentation, and I hope to get any news and feedback. Thank you very much.